Labs are designed for scientists to do their experiments. Our lab is also designed for scientists to work with a machine learning platform. There are a lot of small but important differences. Let's look at those today.
For our E. coli workflow, our cycle time is around 4 weeks. For our cell-free protein expression workflow, we can go from designs to data within 1 week, which is very uncommon. Also for our customers, this is beneficial because the faster you can generate data, the earlier the models get to see that data and act on it.
You can imagine that if we can already get data back to the ML engineers within a week, that we can iterate every week on our models, while if this takes like half a year, we can only iterate twice every year. So that's very important to us, as well as the data quality, where lab automation also helps. Robots do something you tell them very precise and always at the same way. Instead of us humans, if you didn't have your oatmeal breakfast, you would be shaky and you would make mistakes, for example.
Automation is challenging no matter what you're doing, and each sort of workflow needs its own solution, but microbes, so E. coli, yeast for example, are certainly much easier to work with. They grow in a lot of different formats pretty happily, so on a plate, in a 96-well plate, in a big tube, whereas mammalian cells are a lot more finicky and fragile. They need much sort of stricter sterility and growth requirements. Mammalian cells need regular maintenance even when you're not doing any assay on them. All of this requires a lot of different motions and temperatures and transferring between different labware and different steps. So when it comes to automating these sorts of things, there's a lot more requirements basically for like the modules and possibilities we have to have available to us.
So behind me, the microbial lab, we started there with lab automation from the very beginning, but we started out small. So we started only with a VIA flow and Opentron's OT2, but with those two devices we could get quite far, and from that point on we started improving our workflows, getting more powerful machines in. And the same thing is what we're going to do for the mammalian lab. We start out relatively small and we build out our workflow from there. I think this way you can really build your workflow around your lab automation, but also improve on every cycle of your workflow, and that's the only way to really know what you need to get to the perfect automated workflow. So one of the other cool things personally I think about working here at Cradle is we don't have that much IP in the lab work itself, meaning that we can share out to our customers but also to the wider community. And that's cool because we have this high-tech lab, but normally it's like in pharma, it's behind closed walls, meaning that you cannot freely share how a workflow works. Well, for us it's the other way around. The IP is within our platform, and actually we want our customers to work in a similar fashion, because this is how we found we get the most out of our models.
So I think the benefit of having built our microbial lab automation from the ground up means that we did have a lot of learning opportunities throughout that process that we can definitely implement those learnings in the mammalian lab. Different things about working with high throughput liquid handlers, all of that will transfer from what we do in the microbial lab to the mammalian lab as well, which should hopefully help us to avoid some early pitfalls and scale up a little faster, even with the additional complexities that mammalian cells bring.
I'm super excited for the mammalian lab because these workflows are quite different and you need a bit different lab automation. So I'm really curious to where it eventually will go and where we will end up.
From workflows to automation, we had to think about every single detail that went into this lab. Now it's time for everything to come together. In the next episode, I'm very excited to show you the full mammalian lab. Stay tuned and see you next time.